Hi guys, today we're going to be looking at the concept of a binomial distribution, and we're going to be looking at the population mean and the standard deviation for that situation. Now I want to break this formula down for you and just show you it's not scary. I know it looks a little bit different, but it's pretty easy. So if we were using an example of a dice, rolling the dice, then our x1 would be, say, number 1, x2 would be 2, x3 would be number 3, and so on. And then the probability of getting one of those values would be 1 out of 6, 1 out of 6, 1 out of 6. So the definition is the mean's equal to the sum. That's what that means, the sum of those things times together. And then the standard deviation is the square root of this thing over here, and I'll show you how that works, and it's a pretty easy way of doing that. So let's do that now. So if we were looking at, say, rolling a dice, then if we were looking at trying to work out what the mean was for rolling a six-sided dice, then I'd say the mean is equal to simply the sum of xi pi. Now that's going to be equal to simply 1 times 1 over 6 plus 2 times by 1 over 6 plus 3 times 1 over 6, 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. Now if you did that calculation, you're going to get an answer of 3.5. Okay, you have to trust me that that's what you're going to get. It's a pretty simple calculation, a bit tedious, but that's what you're going to get there. Now I'm going to write the standard deviation. I'm going to keep it as a squared one, and then I'm going to say it's equal to the sum of xi, and that's going to be squared, times by pi, take our mean squared. Alright, so that's the formula you want to use. Now that's simply then going to be equal to 1 squared times by 1 over 6 plus 2 squared times by 1 over 6 plus 3 squared times by 1 over 6. Get the idea? Plus dot 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 dot. Okay, plus 6 squared times 1 over 6. And then you've got to take away the square of the mean. So we already worked out the mean. That's going to be take away 3.5 squared. Now if you do that calculation, you're going to get an answer which is approximately equal to 2.91666 and that's what my standard deviation squared is equal to. So my standard deviation is equal to the square root of all of that. 2.91666 would equal an answer of approximately equal to 1.708. Okay, so for most cases we'd probably be happy with just 1.7 as our standard deviation and 3.5 being our mean of our population. Now, looking at an example of that, in terms of looking at the example we previously looked at in our video of the magazines, if we wanted to work out what our mean number of magazines bought per day are, then remember we had 0 people bought no magazines, and we had all this distribution here, then that's what you're going to be doing. So you're going to go 0 times 0, 1 times by 2.23, 2 times by 0.38, and so on and so on. And that will give you a mean number of magazines sold in the day of 2.38. Now this is a slightly different way of using that formula. So this is going straight to the formula using it in the way it was. So remember we've got our X bar, so getting 0 magazine or 1 magazine is going to be 1 take our mean, okay, which is this value here squared, times by the probability of getting 1 magazine. Alright, so that one corresponds to that value there. And then the next one, 2 magazines, so it's going to be 2, and then that's the probability of getting 2, and then we start looking at 5, okay, so that's our 5 value there, and it's 5% chance. So it's a fairly tedious calculation to do, but then you can actually work out what your standard deviation is for that. So that's a way of working out your mean and standard deviations using a binomial distribution for that. Now, I just want to talk about some things that we talked about in our previous video. The Pascal's triangle. Now, remember we used this when we were trying to expand polynomials. Okay, so when we had something like x plus y squared or x plus y to the power 3, the prefixes come from the combination. Okay, these combinations actually take into account all those numbers that we're getting over here. So that corresponds to that. That one over there corresponds to this one over here. So if you did C 5, 2, then you get 10 ways of that happening. So these are all, this is a, an example of a binomial distribution. A binomial distribution takes into account all the different ways of doing things. Alright, so now just want to quickly look at an example in your textbook, and this one here puts into context why we would be doing this. So cheap car insurance insures used cars valued at $6,000 and under these conditions. So what they recommend, what they suggest are these are the categories for their payouts. So $6,000 will be paid to the owner for total loss. The damage between $3,000 and $6,000 will be paid. So they'll pay $3,500 will be paid. For damages between $1,500 and $3,000, $1,000 will be paid. And for damages less than $1,500, nothing will be paid at all. So from this information, what they found out that for probably getting A, it's only 3% of the people who actually have a total loss. Okay, 12% of the people have damages between $3,000 and $6,000, and 35% of the people have damages less than between $1,500 and $3,000, and 50% of the people will have damages less than $1,500. All right. So what the company wants to do, obviously cover their costs. Right, so based on this information, but also wants to make an $80 profit for every policy. Right, that's what they want to do. Now, if you can consider what would happen in real life, it's the same scenario what we're looking at here. So X is the payout value. So this is going to be our distribution. So we're going to have a payout of $1,000. We're going to have a payout of $3,500. And we're going to have a payout of $6,000. Alright, and 50% of the time there's no payout. Alright, 35% of the time you're going to be paying $1,000. 12% of the time you're going to be paying $3,500, and 3% of the time you're going to be paying the $6,000. So if we want to work out our mean for that, okay, we just use our distribution mean. So it's 0 times that. The payout figure is 1,000 times by 0.35. 3,500 times 12. 6,000 times by 3, so that's going to give us an average payout of $950. Okay, so if we want to work out what we would expect to charge people for our premiums, okay, then we've got to add this $80 on to our mean value, and that's going to give us a premium value of $1,030. Okay, so that's how we work out how much we would charge people based on the figures. And so therefore insurance companies will base their premiums on what their payouts have been for the last couple of years and on average, and they insure that way. Alright, so that's an example of an insurance company using the concept of a mean and a standard deviation, and so therefore it would be expected that you would possibly need to know how to do that for a binomial distribution. Right, the formula looks a bit ugly. It's not that actually hard to use, just a bit time consuming. Possibly not likely to be asked something like that in an exam, but certainly I think getting a concept of what you have to do there is important. So have a go at a couple of the questions there. That will give you a chance to play around with these formulas and make sure you know how to use those. All right. So I'll talk to you in class. If you've got any questions, make sure you catch up with me.